A federal network device got backdoored in September 2025, survived a full patch cycle, and nobody noticed until CISA and the UK's NCSC published a joint advisory about it in April 2026. That 7-month gap is the number you should be sitting with right now. Here is what is actually confirmed. An unnamed U.S. federal civilian agency was running Cisco Firepower hardware with adaptive security appliance software. At some point in September 2025, a piece of malware labeled Firestarter was installed on that device. CISA and NCSC jointly assess Firestarter as a remote access backdoor. The critical detail, and the one that should make every network engineer in your organization uncomfortable, is that the backdoor survived security patches applied to the device after compromise. The malware persisted through what should have been a remediation step. That word survived is doing a lot of work in the reporting, so let us be precise about what it does and does not tell us. Surviving a patch means one of a small number of things. Either the malware established persistence in a location the patch process does not touch, firmware, bootloader, a management partition, a hypervisor layer underneath the OS, or it was reintroduced after patching through a still open access vector, or there is an undisclosed zero-day that allows recompromise on reboot or update. The CISO advisory, based on what has been reported so far, does not publicly specify which of these mechanisms applies. That is frustrating but not unusual. Attribution-sensitive investigations often redact the exact persistence method because disclosing it tells the attacker what was discovered. What CISA and NCSC are willing to say publicly is enough to draw serious conclusions. This is a nation-state-level capability. The joint advisory format, US CISA plus UK NCSC, is the same publication pattern used for Russian GRU, Chinese MSS, and Iranian MOAS attribution campaigns. They have not named a threat actor in the reporting available so far, so this script will not speculate on attribution. But the operational profile, a persistent implant on a perimeter device at a federal civilian agency that survives patching, is consistent with the kind of long dwell time access campaigns that intelligence services run to maintain persistent footholds rather than to immediately exfiltrate. Now let us talk about why Cisco ASA on Firepower hardware is a particularly attractive target for this kind of operation, because this is not random. ASA software is one of the most widely deployed firewall and VPN platforms on the planet. Federal agencies, defense contractors, financial institutions, healthcare networks, ASA is everywhere. It handles encrypted VPN termination, which means an implant sitting on an ASA device is positioned to intercept credentials, session tokens, and in some configurations decrypted traffic before it hits your internal network. That positioning is enormously valuable to an intelligence operation. You are not just on the network, you are at the front door watching everyone who comes and goes. Cisco ASA also has a history worth acknowledging. CVE 2023-20269 was a zero-day in ASA's remote access VPN that threat actors exploited for credential brute forcing at scale. Before that, the Shadow Broker's leak in 2016 exposed NSA-developed exploits for ASA, some of which remained unpatched for years. CVE 2018-0101, a remote code execution in ASA's SSL VPN, had a CVSS score of 10.0. The platform has a long tail of high-severity vulnerabilities, and because these devices sit at the perimeter and are often managed by a small team or a managed service provider, they sometimes get less scrutiny than the servers behind them. Attackers know this. The persistence through patching detail specifically points toward what the security research community calls a firmware implant or a bootkit-level persistence mechanism. There is prior art here. Researchers at Mandiant and others have documented implants for network devices, routers, firewalls, load balancers, that install themselves into flash storage regions that the normal software update process does not overwrite. Cisco itself published guidance in 2022 on detecting implants in iOS and iOS XE devices after a campaign, tracked as part of the broader router implant wave, targeted network infrastructure globally. The technique is not new. What is notable is seeing it confirmed on ASA specifically in a federal environment in 2025. There is also a supply chain angle worth flagging because CISA advisory language leaves it open. Supply chain or zero-day persistence mechanism is the framing, and that framing matters. A supply chain compromise would mean the device was implanted before or during delivery, or that a trusted software update channel was weaponized. If that is the vector, patching does nothing because the patch itself could be a delivery mechanism, or because the implant lives below the layer that patches touch. This is a harder problem than a conventional exploit, and it is why CISA operational guidance for this kind of incident typically involves physical inspection, firmware hash verification against known good images, and in some cases hardware replacement rather than software remediation. Here is what the tech press largely missed in covering this story. Most of the coverage is a restatement of the CISA advisory with minimal analysis. The framing tends to be federal agency got hacked, Cisco device bad. What is underreported is the operational implication for every organization running ASA that did exactly what they were supposed to do. They applied patches, and may still be compromised. Patch compliance is necessary, but not sufficient when you are dealing with firmware-level or supply chain-level persistence. That is a qualitative shift in what remediate means for perimeter devices, and it has direct budget and process implications for your team. Let us get concrete about what you should actually do with this information. First, inventory your ASA deployments right now. Know which firmware versions you are running, which devices are firepower hardware versus legacy ASA hardware, and which ones are exposed to the internet for VPN or management. If you do not have this inventory, that is your first problem and it predates Firestarter. Second, verify firmware integrity. Cisco provides tools for this. The Cisco Trust Anchor module and secure boot features on Firepower 2100, 4100, and 9300 series hardware are specifically designed to detect unauthorized firmware modification. If your hardware supports it, and you have not verified it recently, do that. Cisco's TAC can walk you through the process. For older hardware that does not have these features, your options are more limited and your risk is higher. Third, check your management plane exposure. ASA management interfaces should never be reachable from the internet. If yours are, fix that today, not this sprint. ASDM and SSH access to the management interface should be source restricted to your management network. This is basic hygiene, but it is also a prerequisite for limiting the blast radius of any implant that requires management plane callbacks. Fourth, look at your logging. ASA devices generate logs. Those logs should be going to a SIEM or at minimum to a syslog server you actually review. Indicators of compromise for firmware-level implants often show up as unusual outbound connections from the device itself, unexpected process activity, if you have any visibility into the device's management plane, or anomalous VPN authentication patterns. If Firestarter is a remote access backdoor, it needs to call home. That call should be visible in your network flow data if you are collecting it. Fifth, if you are a federal civilian agency or a critical infrastructure operator, and you have not already engaged with CISA known exploited vulnerabilities catalog and their advisories on this campaign, do that. The advisory will have indicators of compromise and specific detection guidance that is more detailed than what has been published in press coverage. One more thing worth saying directly. The gap between September 2025 compromise and April 2026 disclosure is 7 months. In that window, the implant was active, and the affected organization presumably believed they were secure because they had patched. This is not a failure of patching. This is a failure of the assumption that patching equals remediation for sophisticated, persistent threats on network infrastructure. Your perimeter devices are not servers. They have different firmware update models, different persistence surfaces, and different monitoring tooling. They deserve a separate threat model, and if your current security posture treats a firepower device the same way it treats an EC2 instance, that gap needs closing. The real story here is not that a federal agency got hacked. Federal agencies get targeted constantly. The real story is that a well-resourced attacker demonstrated the ability to persist on Cisco ASA hardware through a patch cycle, which means your standard incident response playbook for this class of device needs a firmware verification step added to it, and your definition of remediate needs to change.